It was something that I started last quarter just to help everybody out. It turned out extremely well. A lot of people really liked my way of subnetting, and so we decided to make it a quarterly thing after Mr. Apperson unleashes the STEFCO Kraken on everybody. Basically, the reason why I did start this is because subnetting sucks. It really, really does suck, especially when you first start subnetting. You get confused, you got to convert that to binary, you got to convert this to binary. When I first started it, it stressed me out and I didn't really know how. I became dependent on what's called VLSM calculators, which is basically just a calculator that does everything for you. I didn't want to do that anymore. I wanted to know how to do it by hand. And so one night I literally just kind of designed my own algorithm on how to subnet. And that's basically what you guys all got right now. You guys are going to see the top layer of the top 3 ones. Those are going to be the only ones you're going to concentrate on right now. Don't look at the bottom row, just because that's going to be class B addressing, which is a huge, huge network. You're not going to have to pay attention to that. So just pay attention to the top one, which is class C, which I don't know how many of you guys are in network fundamentals right now, but STEFCO is a class C network. So just concentrate on class C for right now. Also, what is subnetting? Subnetting is basically taking a huge network and dividing it into smaller subnetworks. So it's basically getting a house, and instead of looking at it as a house, you're looking at it as individual rooms. It just makes it a lot easier for you to just segregate traffic. It just flows a lot better that way. Also, so I'll go ahead and show you what my algorithm is. When it comes to subnetting, the only thing you're going to have to remember if you're going to subnet my way is 128 and /25. That's the only thing you guys are going to need to remember. That's the only thing. Everything after that is literally simple math. If you want to go step by step, all you have to do is look at the 128 and laser. What's half of 128? And you literally just do that until you get to the number 1. Amber, what's half of 64? Gootsy fruits. What's half of 32?
Gootsy fruit.
Mr. Jenkins, what's half of 16?
8.
This might be a little hard for you, Mr. Dalton, but what's half of 4? I mean, half of 8. Half of 8. Okay.
I know the next one now.
You do? You sure? Perfect. And I think half to 1. That's all you're going to have to remember for the first part. Do you see why the only thing you're going to need to remember is 120 and /25? Because everything else other than that is just going to be simple math. For the /25, all you're going to have to do is just add 1. That's it. So, what's 25 plus 1 total? And even I can manage plus 1. I never go past 30, just because you're never going to have a subnetwork that's past 30, not that I know of. So just concentrate on getting to 30, and that's it. And, huh? Oh. I guess I can. Okay, there we go. Yeah, never happened. But yeah, that's the key that you guys are going to use in all the subnetting I'm going to teach you. Just with this information, you're able to subnet anything. You could do classful subnetting, which is basically subnets that have the exact same amount of hosts each time. And then there's the variable length subnet masks, which are the ones that require different hosts, so you kind of have to adjust your subnets a little bit. For instance, we'll go ahead and concentrate on what is called classful subnetting. I wanted to teach you guys classical subnetting first, just so you can get a handle on how to use the algorithm. Classical subnetting is relatively easy, so you guys will be able to do it with no problem. But I want to just teach you guys how to use this key right here, because like I said, the key is going to tell you everything you guys are going to need. Let's say Mr. Dalton told us to go ahead and subnet this address, 192.168.1.0. So that's going to be what's called our network address. And let's say it's a /24. So let's say he also wants 3 subnets using this network address. And if he wants 3 subnets, he's going to want 50 hosts in each one. So I'll go ahead and put that 3 subnets. 50 hosts. And again, if you don't really know what subnetting means, basically what I'm going to be doing is getting this network address and turning that into 3 smaller networks, 3 subnetworks. Okay. First, you're going to have what's called a network address. Then, in between that, you're going to have the hosts, which are basically going to be the addresses for your computers, your printers, servers, anything like that. After that, you're going to have your broadcast address. To create a simple analogy of what those actually are, imagine if your network is a house, the network address is going to be basically the address of the house. The hosts are going to be everything that's in the house, so it's going to be your computers, it's going to be your printers and everything. Broadcast address is going to be your address to get out of that house. So in every single network scheme, you always have to reserve 2 addresses for the address to your network or your house, and the address and how to get out of there. So, like I said, let's say Mr. Dalton gave us 192.168.1.0. So the first subnet, we'll go ahead and just call it subnet A. It's going to be 192.168.1.0. And he wants 50 hosts on that. When it comes to subnetting, you can only go over. If he wants 50 hosts, and all of these right here are the number of hosts that these subnets can handle, so I'll go ahead and label them hosts. Which one of these sections would support 50 hosts?
64.
64. And so we know that we can only give this subnetwork that many addresses. Let's go ahead and just jump to subnet B. This is where the algorithm is going to come into play. To be able to quickly find what the next network address is going to be, all you have to do is be like, okay, so this requires 50 hosts, and like you guys said, we're going to be looking at that one for that network address. And what you do is you see, okay, there's 64 on there. What's 64 plus 0? It's a little hard, I don't know. All you have to do, just get that last guy right there, just add 64, which is what you're looking at because you wanted 50 hosts per address. That makes that. So, let's go to the next subnet. Again, he wants 50 hosts for each one. So, we're going to go ahead and say, okay, this has 64 hosts. Obviously, you can't do 32 because, like I said, you can't go under. So we're going to go to this guy again, which is possible subnetting, exact same amount of hosts. And we'll go 192.168.1. And then 64 plus 64 is
128.
Just by doing that, you've got the network addresses for all your subnets. For the broadcast address is always going to be the last usable address on that subnet. It's going to be the last one. So, go ahead and write out. And if you want to find out what the last one is, all you have to do is just look at the next address that the next subnet is using, so the network address, and it would just be the address that's before that. So what's 64 minus 1? 63. And then using that logic, what would be the broadcast address for subnet B?
So you're basically using our cut sheets in our final project and they're down below. So you're not putting in like the /26, for example. Is that actually unnecessary in your cut sheet?
You can use /26. If they want to know the if they want to know the subnet mask, you can use that. And I'll go ahead and explain subnet mask at the very, very end. But yeah, it does kind of become necessary, and it's a little handy tool, especially when you're doing variable length subnet masks. What I usually like to do is like subnet A, I'll put, okay, that's /26. Now it's going to be /26, and now it's going to be /26. Just so it's like easy reference, so I can be like, okay, I just need to look at that guy right there. Just need to look at that guy right there. Just need to look at that guy right there. You kind of get what I'm saying? Okay. So I usually like to use it as reference. And also, the last one is just a little tricky, since you're not looking at the next network address, since there's not another network. So you kind of create a pseudo network. Again, 50 hosts on subnet C, and so 128 plus 64.
192.
How much is it?
192.
192. So if there was going to be a next network, it would be ending in 192.
Right.
So
it'd be 191.
191.
Right.
So 191 is going to be the last broadcast address. That's something that doesn't exist, so you can just go ahead and erase that. And other than that, it's just basically simple math logic to find out the hosts. Okay, so for this subnet, you're using the .0 for the network address, and you're using the .63 for the broadcast address. For the hosts, and then it's just going to be everything in between those guys right there. So that plus 1 is going to be 1. And then the one address before that, 62. That's it. So you just completely subnetted that next network. So what would be the next address the host can use for subnet B?
65.
And then what would be the last one that you can use? And then what's the first usable host for subnet C?
129. Through 190.
Alright. And just by plugging in the addresses that are in between the network address and the broadcast address, you went ahead and completely subnetted the address that Dalton had given to us. So do you guys kind of understand how to use the algorithm here? Basically, all you really have to do is think, okay, so 50 hosts, this thing right here is going to support that, so we just know it's going to be 64 in between each last one. So it'd be 0 plus 64 equals 64, 64 plus 64 is 128. And just by having those network addresses, just by using simple logic, you're able to actually just figure out everything else. Using this way, you don't have to convert to binary, you don't have to do any of that kind of stuff that makes subnetting extremely difficult to understand at first. So that's why I kind of prefer that way, and everybody else that I've talked to much prefers it that way also. So yeah, that's basically what classical subnetting is. Go ahead and erase that. Does anybody have any questions before I move on to class list subnetting?
Doing one doesn't matter if you have to take 1, 2, doesn't matter.
What's that?
Like at the bottom, here 30, 29 to 30.
Yeah.
Next one's 31.
Oh yeah, /31/32. You don't really need to, just because
You never get them.
you're never going to use that. Yeah. The only reason why you would ever, well, I can't think of a reason why you would ever use that.
There's not really a reason.
Yeah.
Because you have to have the extra 2. Remember, you got the host and you got the broadcast. You have 2 added on to everything. If you're looking at the /31, that's 2, which means you only have the host, you only have the broadcast. There's nothing usable.
Yeah, because remember, you always gotta have 2 dedicated to the network address, and you gotta have 1 dedicated to the broadcast address. You can't use those for hosts at all. Like I said, that's the network to your house, well, that's the address to your house, and that's the address how to get out of your house. What we're concerned with is everything that you can use in there for the usable hosts.
Actually, the minimal functioning network would be free, and that would turn out to be a full radio.
Yeah. So, like, let's say you just needed a network with only 2 hosts. You would do the 4 because one of them is going to be reserved for the network address, and the other one's going to be reserved for the broadcast. So it would have to be that 4 right there. So you guys ready for STEFCO?
You bet.
Okay. Let me look at what's Mr. Apperson.
Probably the same thing you wanted to tell me.
Yeah. Yeah, 68 hosts.
Yeah.
Yeah, when I first saw STEFCO, I was scared. I came in here wanting to be a network administrator. I came in here wanting to major in network administration. Once I saw STEFCO, I was seriously thinking about switching majors and going to some other pointless one like philosophy or something.
A big dollar in that.
But no, I think we're all scared. We're all scared once we saw STEFCO. So that's why I wanted to do this for you guys, so you guys realize that STEFCO is actually somewhat easy once you get rid of the fear of subnetting. So hopefully that's what I'm doing for you guys. And you know how I said each subnet was 50 hosts in the first one? That's classical subnetting. Classless subnetting isn't a set amount of hosts that's the same exact way. So, like, for instance, a classless subnet would have been subnet A was 50 hosts again, subnet B would have been 40 hosts, subnet C would have been 10. That's what classless subnetting is. So, let's go ahead and do STEFCO. So, he wants Yakima to have 68 hosts. Richmond, 36. He wants 15. Wenatchee wants 10 hosts. Prosser, he wants 8. And he gave us an address of 172.18.4.0/24. Alright, so that's the network address. That's the address to the house that Mr. Apperson wants us to have, and he wants us to divide into 5 smaller networks. And so, these are the amount of hosts that are going to be in each one of those houses or networks. So, let's go ahead and look back over here. Yeah, you always want the largest to smallest. That's actually out of order than what Mr. Apperson gives you on the piece of paper. So it always helps if you go largest to smallest. And another key thing too is, you know how we use /25, /26, /27? One thing I wasn't too clear about when I first started subnetting was I didn't realize you can use those over and over again. You can use the same subnet mask for different subnetworks. I thought that one of them was going to be /24, so the next one had to be /25. The next one after that had to be /26. You can use all of them as /26s or /25s. It doesn't matter. You can always use the exact same one. So that's one thing I was a little caught up on at first. So let's go ahead and go to Yakima. the ones reserved for the network address, or the address and how to get to our house, the host. The broadcast address. Okay. So he gave us the network address 172.18.4.0 to subnet. So the first one's going to be 172.18.4.0. He wanted us to have 68 hosts. So again, using the key, which one of those is going to support 68 hosts? 128. So it's going to be a /25. Next one is Richland. Richland is going to be host 36. Which one of those is going to support 36 hosts? 64. See, that's 64 /26. So just for reference. Okay. So all we have to do is say, okay, /26, 64, since it's 36 hosts, and that's what's going to support it. And also, we wanted to find the network address. Remember how to do that? Again, you go back to the Apple one, you see that's /25, so you can use 128. So what's 0 plus 128? 128. There you go. Next one is Ellsworth. With 15 hosts. I hope you guys realize, like, I'm not even subnetting. I'm basically just asking you guys for help, and you guys are doing it for me. So, Ellsworth, 15 hosts. Actually, before we figure that out, let's go ahead and figure out the network address for it. So Richland was 36 hosts, right? And you guys told me that that's the one we're going to be looking at. So, to find the network address for that, how are we going to do that?
And 192.
Yep. So 128 plus 64. 192. The next one is Apache. With 10 hosts. And Wenatchee requires 10 hosts. So which one am I going to be looking at for Wenatchee?
/28.
224?
Yeah.
And how did you come up with that, Mr. Jenkins?
Adding 32 to 192.
Yep. And you guys got how we did that? Basically just looked at here, okay, so this one's a /27, 32 hosts. So to find the next one, 192 plus 32 equals 224. Last guy, process. Remember when I said a little bit ago how you can use the same one? It doesn't have to be consecutive at all. So considering that that's 8 hosts, which one would we be looking at? Remember, we gotta have 2 addresses reserved for the network address in the broadcast. So 16, exactly. So last one's going to be /28. And then considering that that one was a /28, also because it's 10 hosts, what's 224 plus, since that's /28, we're going to go up to here. What's 224 plus 16?
240.
240. And there you go, you just found out the network addresses for each one that you guys are going to need for STEFCO.
And the broadcast host is going to be one last.
Yes, the broadcast address is always going to be the last usable on there, so it's always going to be the one that's before the next network address. So, 172.18.4.127.
Now we can just
Okay.
that.
172.18.4 dot, what would be the next one? 191. Anyone wants to do the next one? What's that? 220. Yep, 239. Like I said, the last one's always a little tricky, so you kind of have to make up a pseudo network just for the next one, a network that doesn't exist. So since we saw that this was a /28, we just got to reference that right there and say, okay, so 240 plus 16 is 256. And so the last broadcast address is going to be what?
255.
There we go.
And then the last step where we go slap Stef for making it so cloudy.
Yeah, doing it this way, you just bypass everything. Well, you bypass binary, which I hate converting to binary. You shouldn't have to. And that's the reason why I did this, because it's a lot easier. I kind of stole half of this from Dalton's way of subnetting, the magic number. I just made it a little bit easier, just because you can use this key as reference. So for the hosts, I'm not going to write out the 172.18.4.0 or .4, since you guys already know that. So what's going to be the next one? .1 through
7.6.
okay. Dot. So you guys getting it?
Yeah.
What's the last one? What's the next one? 238. 241. And there you go, guys. You just completely subnetted by hand STEFCO. Even in the STEFCO project, what he originally asked you for is to do it through a VLSM calculator because, I don't know, maybe he feels like it's a little bit too hard for you using the way that he teaches you. So hopefully with the way I taught you, you can see how it's actually pretty simple to subnet. Just by using that key, the only kind of math you really have to do is having this 128 and then just adding 1 to the /25. That's it. Other than that, you're literally just using it as reference. Yakima, okay, it was a /25, so we just reference that. Version that was a /26, so we just reference that, and so on and so forth. And that's basically it for subnetting. If you guys can subnet these addresses, you guys can subnet anything that any of the teachers are going to give you. Because basically this one was actually made to make sure that you guys actually know something. And also, like I said, he wants to use the VLSM calculator. You So good job, guys. I didn't even have the subnetting.
All right,
You guys
good
just done
job.
it for me. So.
By the way, for everybody heads out, us four up here have all done STEFCO. We all got, I just need Matt got 100 and another 100 here. So if you guys need help on it, or if you want somebody to look over your stuff, come on down to Sunquist. We're usually down there. Just come flag us down. We can have a look at it and give you guys a hand.
Exactly.
You will.
And Mr. Apperson tries to make it sound like it's impossible to get 100. From the way he told us, we thought nobody has ever gotten 100, and yeah, all of us, except for Bootsy, got 100.
At 99.
It's just, was it facebook.com/group/YVCC IT club? I think that's it.
And this will be on YouTube.
Oh, nice.
You're gonna go to YouTube.
Oh, you go buy.